Well, let's just get started then. Hi, everybody. My name is Nick, KK7LZM, and I'm going to tell you a little bit about AREDN, and especially about AREDN here in Seattle. So how many of you are already familiar with AREDN, or maybe you've heard the name a little bit? So we got, yeah, so maybe a third or a half of the folks here. Great. So AREDN is it's a digital radio mode. And what it does is it lets us run TCP/IP over amateur radio bands using consumer-grade Wi-Fi hardware. And so what that means is that we can use computers to do internet-like stuff, just like, you know, open a web browser and use chat programs and things like that. But all of that runs over amateur radio bands, and then that's all sort of facilitated by just regular consumer Wi-Fi devices, like the one you might have at home, your Wi-Fi router. And so these run on frequencies that are right next to Wi-Fi bands. So these run on like 2.4 gigahertz, just like your home Wi-Fi, but it's like maybe 20 kilohertz below where consumer Wi-Fi runs. The way that AREDN works is that we have these Wi-Fi devices that operate a lot like what you would have in your home router, but they are self-organizing mesh nodes, which means that when one of these comes online and another one sees it, they're going to automatically pair together and start transferring traffic. And so I might be able to, on my computer, be running some service like a website, and if I have one of these out here running and then someone else just brings up their device, we're going to connect together, and then that person can use their web browser to get my website on their computer. And this is really interesting, right? Because this lets us create this sort of resilient and self-organizing network to facilitate a bunch of different kinds of services that are super similar to stuff that you're already using on the internet. In fact, things that non-hams might already be using. So for instance, a lot of hospitals use a bunch of different software to manage patient records and things like that. And if their cable internet goes out, or their fiber internet or whatever it is, all of those tools that they have immediately go offline because they are entirely dependent on that fiber internet. So the point of AREDN is to create sort of a parallel internet infrastructure to carry exactly that kind of data over it. And that might be data that's going to go out to the open internet, right? We might have, you know, this node might be running at a hospital, which might be talking to someone else's node down the street at a house that might be talking to another node on the other side of the city. And even if the internet is down here, because we have these radio frequency hops, if this node is connected to the internet, it can actually bridge that internet back to that original site. And that self-organizing part is part of how this is resilient, in that all we need to do is we need to get someone else to put up a new node, and as soon as they mount it on their roof or a tower or whatever and turn it on, it can join that mesh, and all of the nodes are going to start talking to each other and decide how they should route the traffic between them. So if, for instance, we start with a setup like just these three nodes like we had before, and maybe the connection between these two is not great, if someone else joins the mesh, automatically, instead of traffic going straight from here to here, it can now bridge and sort of relay through, just like a repeater or a digipeater, through this node. And all of that happens automatically. There's no configuration or setup that you need to do to make that happen. Yeah, so the use cases for this, probably the number one use case is for emergency communications. Um, and in particular, being able to provide that digital, like traditional internet-like technologies, like web browsers, like chat programs, like email, um, without having to install or run any special software on my computer. I can plug it into the mesh, and I've got access to that sort of parallel internet infrastructure, which obviously in an emergency situation could be a really big deal, right? Like if Comcast is hit by a cyber attack, the amateur data network is probably not going to get hit by a cyber attack because nobody knows about it. And so that could be an important tool in a scenario like that. So for instance, actually the West Seattle Amateur Radio Club, we have a bunch of nodes installed at nursing facilities around West Seattle. And part of the pitch to those nursing facilities is, in an emergency, we're going to have this node here that's part of this resilient mesh. And if your phone goes down, if your internet goes down, we can drop a line from this, just like an Ethernet cable down from the roof and plug in your IP phone or plug in your computer and get plugged into that network. And at least be able to operate access services that are on that mesh. And if the mesh is able to get out to the internet, it can provide internet through the mesh so that there would be basically zero interruption to the communications for that site. Yeah, so this is a lot like WinLink in that it's providing, WinLink provides email over amateur radio. But this is a little bit more pervasive because it's not just providing sort of a bridge to email the way that WinLink does. It's providing sort of this low-level transport for exactly the kind of data that your computer speaks for all of its internet services. Great. So what I keep talking about these services, and I keep talking about sort of this parallel internet. And an important distinction is that we're going to create this parallel internet, but that parallel internet might not have stuff like Amazon or Google or the things that you're used to. It's possible that we would have a bridge to the broader internet, but if that bridge doesn't exist or the broader internet connection is down and none of the nodes have access to the internet in the mesh, then the services that are going to be available on the mesh are going to be things that we as hams are running on the mesh. And so these services are things like, there's a chat program that gets run, and so there's something called Mesh Chat that ACS has a Mesh Chat instance that's running, and the West Seattle Amateur Radio Club has a Mesh Chat instance that's running, which is sort of like a chat room where we can exchange chat messages, we can exchange data files as well, and all of that sort of runs on that mesh. And so as long as one of those nodes is up and you're able to talk to that node, you're able to access that mesh service. Other kinds of services are IP phones. So if you're working in an office and you have a desk phone, that phone is almost certainly an IP phone. And it uses the network in your office so that you can call other people in your office. That exactly, like literally those same phones, you can plug into one of these machines, and then we have an IP phone on the mesh. And so there's actually a few people in the West Seattle area that have an IP phone on their node. And if you have an IP phone and you're on the mesh and you know what their IP address is, you can just pick up the phone and dial that in, and it'll ring for them just like it was a telephone, like a desk phone or something like that. Other kinds of things are video cameras. So just like you might have a ring cam and you can pull out your phone and you can look at your ring cam, if you can connect to the mesh and you have a video camera back at home plugged into your node, that video camera can be broadcasting its video signal on the mesh. So for instance, I think Tom, who from the club, N7 OEP. He has a video camera that's looking at his yard that he's plugged into the mesh, and you can visit his mesh node and look at his video camera. Other kinds of services that people often run are weather stations. So if you have a little weather station, an IP-based weather station, it's totally the same thing you would buy off of Amazon to like a network-enabled weather station or something like that. You could plug that into the mesh, and then that weather station would be available on the mesh. Or computer-aided dispatch services. That's another thing that some folks in California have an emergency operations center with a computer-aided dispatch service that runs on a mesh that's running across Southern California. And they use the mesh that's created by all of the nodes that they have deployed there in Southern California to provide an internet dispatch service, except instead of running on the broad internet, it's running on the AREDN mesh. So the point of AREDN is not that it offers any one of these services. The point of AREDN is that it's providing kind of this fabric on which lots of services that already exist that don't have to care about AREDN at all, they're just internet-enabled devices, they can plug into that fabric that's created by the mesh. And so these services then can be deployed by an organization like ACS, for instance, right, where they might be really interested. In fact, Tim was just talking about how one of the things that they're really interested in is having localized weather reporting that they want to have. And the way that they do that right now is they, pick up their HTs and say like, hey, I need someone from the Admiral neighborhood to go outside and give me I need to know what the temperature is, I need to know what the precipitation is, I need to know what the road conditions are. With the AREDN, if we had the AREDN mesh running, even if all of the internet was down, as long as the mesh is running, if there was a weather station in Admiral, Tim could just plug his laptop into the mesh and then go navigate to that person's node and see what their weather station is reporting. So that's like that's probably the primary use cases to enable these kinds of emergency communications. Yeah. So right now in Seattle, the AREDN mesh is at a very early stage. We have a bunch of pockets that have, there's maybe one or two nodes over here that can talk to each other. And then there's one or two nodes over here that can talk to each other. We're missing an important link in between. So we have a bunch of these pockets where, sure, this person might be running a weather station and this person might be able to get their weather readings from their node. But this person over here, because the mesh doesn't have a link between the two, they're not able to get that weather reading. And so right now we effectively have a bunch of little meshes all over Seattle. A bunch of these nodes have what's called an internet tunnel into the Emergency Operations Center downtown, which does link them. But it's kind of cheating because it's sort of like this node then plugs into the internet, and then the internet plugs into this guy, and so they're connected that way. But the whole point is to not have to rely on the broader internet to provide these internet-like services. So as far as that emergency communication scenario works, we can't rely on that internet connection working, those internet tunnels. So we are left with these very isolated pockets of AREDN coverage. The vision is that I would be able to turn this node on right here, right now, and it would see another node, maybe at Providence Mount St. Vincent, where we have an AREDN node right now. And if I could see that node, then I would immediately be plugged into the mesh, right? That's sort of that idea of this self-organizing, resilient mesh that all I have to do is turn the node on and now I'm plugged into it. It's sort of like municipal internet, right? Or municipal Wi-Fi, right, that we've talked about. That's the vision. We are pretty far from there right now. We would like to get more coverage so that we have this fabric. We would like especially some of these key sites to have backup power. In fact, some of the key sites we already do have backup power, but we're missing a lot of coverage, right? And the thing about AREDN is that we really rely on individual hams to think that this is interesting and cool, to buy one of these devices, install the AREDN software on it, and then stick it up outside their house. That's the way that the mesh is growing in Seattle. I think we have about maybe a half dozen key sites that have AREDN where they're maintained either by ACS or the West Seattle Amateur Radio Club. But there are probably 40 or 50 nodes total. So the vast majority of the nodes that exist are just people putting up one of these nodes at their house. Every time that happens, we get more coverage though. And so we're working on adding some more nodes to sort of complete this mesh. Some of the things that we're doing with AREDN in Seattle is that general emergency communications, right? This is, I think Tim talked a little bit about HamWAN, which is very, very similar to AREDN. In fact, the two cooperate, and I'll talk a little bit more about how that works towards the end. But general emergency communications is one thing that we are actively doing with AREDN here in Seattle. Another scenario is for the West Seattle Grand Parade, which is coming up next month. We're hoping to have an AREDN mesh running up and down California Avenue to operate in conjunction with the voice UHF that we're going to be running just to help support the parade. We'll have this digital mesh that we can use to, maybe we can take a picture of somebody, put it on the mesh, you know, if there's a child that's lost, we got a picture of the child, we can identify who that is, or somebody loses an object, we can send that information out, and if someone finds an object, we can take a picture of that and see what that object is. So we can use some of these things that are much easier in a digital context than they are with just an HT. For that West Seattle Grand Parade. So we'll probably end up putting up a mesh along California Avenue to support that. It'd be great if the mesh was already there along California Avenue. Unfortunately, we don't have enough sites along California for that to work right out of the box. Another thing that some people have been starting to do and talk about using AREDN for is to have a mesh chat net. So just like we might have a net with our HTs, you know, where we call in, do check-ins over that, we might do a net over mesh chat where we can check in on mesh chat and say, hey, you know, I just type in my call sign and there's a net control taking attendance just like they do on a voice net. And just as another way to exercise our radio operating skills, in this case, the digital mode. Yeah, so we are trying to expand to add some more key sites. We have a number of sites that we've identified that are, you know, they've got all the right properties, right? They got to be high up, they've got to be willing to host this device, which a device like this takes about 10 watts to run. And so we do need to plug it in. It does need electricity. Even better if the site has emergency backup power, because then it's actually reliable and in the case of an emergency. And so we have a bunch of those sites. But we're also looking for more people to, like yourselves, that might be interested in just getting one of these devices. I think these devices are, you know, in the range, like a device like this might be 20, 25 bucks. A device like this might be 50 bucks to set that up. If you're interested in that kind of thing, there is a group called Northwest Mesh. So that's nwmesh.groups.io. So we have a Groups.io news group that you can join where we meet once a month and we talk about this stuff. We put on a lot of AREDN workshops where we get hands-on with these devices and install them and walk people through setting it up, and in a classroom setting, set up a little mesh so that you can all see what that's like. and then people take it home, set it up at home, and then now we've got another node. We haven't quite hit the critical mass where once you get home, you turn it on and now you're part of the big mesh. But the way that we're going to get there is by getting more people to install one of these devices. Yeah, so I mentioned HamWAN earlier. So how many of you have heard of HamWAN? Yeah, a bunch of you, about maybe a slightly overlapping group. So HamWAN, super similar, right? HamWAN is TCP/IP over amateur radio. And HamWAN is really focused on bridging internet access. So it's much less focused on these services that are running on these nodes, like inviting someone to put a weather station on the AREDN mesh and then making that locally available, or getting someone to put up a chat server and making that available locally. HamWAN is way more focused on, I have a HamWAN dish, I'm connected to the data ring, I don't care what's on the data ring because the data ring is providing internet to me, and then I go and I do stuff on the broader internet. Similar technologies, both are TCP/IP. HamWAN is focused on this actual internet. AREDN also has this self-organizing mesh aspect, where if a new node joins the mesh, the existing nodes that can see that will automatically respond by making decisions about how to route traffic. So if there was a weak link before, a new node pops up in the middle of that, and those two nodes will stop talking to each other and use the intermediary to relay their traffic. HamWAN doesn't do that. HamWAN is much more manually configured. In some ways that's nice because it means that all of the nodes in HamWAN are pretty reliable and very carefully maintained, whereas in AREDN, there's just like lots of people that decide they want to put up a node, and now that's a critical node, and that person decides that they want to take it down, and now we've lost a critical node. That doesn't really happen with HamWAN, but it happens with AREDN all the time. On the other hand, it does also mean that, you know, Susan can go home and put an AREDN node up, and it'll automatically join the network, and we don't need to have everyone else around her know that she's gone online and make our nodes talk to her node. Yeah, so there's a bunch of challenges. I sort of have talked about how AREDN relies on individuals to sort of provide the mesh. There's some other really important challenges too, especially about topography. And a really interesting thing happens with these Wi-Fi nodes. Suppose that this node is on top of a hill, and it can talk to these two nodes over here. But these two nodes can't talk to each other. There's something called the hidden node problem, where because this node doesn't know about that node, these two nodes might talk at the same time to this node, which causes this node to not be able to hear either of them, right? This is like if both of us key up on our HTs at the same time. It's exactly that problem. Because we have this mesh with all of these, you know, this hop to this hop to this hop to this hop, this can happen a lot, that we end up with these hidden nodes. And so the AREDN organization talks about something called channel planning. And one way to get around this is if this node actually has two Wi-Fi nodes, then it can be talking on one channel to this node, and then this guy can be talking on a different channel to that one, and there's a lot less interference that way. This starts to get complicated, and it's not something that we've investigated a lot here in Seattle. Right now in Seattle, we're going everything is default, so as soon as you install AREDN, it automatically starts working, if you're on 2.4 gigahertz, it automatically starts working on channel -2, which is how all of Seattle is deployed right now. Every single node in Seattle right now is talking on exactly the same channel, which makes it super easy for someone to just turn on a node, and if they could potentially see someone, they'll automatically just start talking. It does cause this hidden node problem to potentially be a problem. I guess we're kind of fortunate because we don't have a complicated enough mesh right now for that to really be a problem. But this channel planning activity is something that they talk about a lot on the AREDN website. Yeah, so I think as the mesh grows here in Seattle, we'll probably have a lot more sort of planning activities about where we want to have nodes, which nodes we want to have talking to which other nodes, and things like that. If you're interested in that kind of thing, that's exactly what we talk about at the Northwest Mesh meetings every month. It's a lot of fun. You know, mostly we just chit chat and have signal reports. But as the mesh is becoming a little bit more robust, there's a lot more planning that's going on. Yeah, so cool. I guess that's about all I had planned. Are there other questions that we want to talk about? Yeah. I mean, it's just Wi-Fi, right? So it's exactly the kind of, I mean, this is a consumer Wi-Fi device that you could use at home that runs on 2.4 gigahertz that offers, you know, hundreds of megabits per second of bandwidth. So yeah, totally. Obviously, that's going to fall off as you get farther away and the signal gets worse and worse and worse. The kinds of bandwidths that the AREDN interface reports, when it sees another node, it does a speed test and it gives you an estimate of what your bandwidth for that other node is. Those numbers that I've seen are usually in the tens of megabits. But it's fast enough to do video chats, certainly. Are there other questions? Yeah, back there.
You mentioned hooking a hospital's kind of patient information up to this net, but as ham radio operators, we're not allowed to encrypt any data.
Yeah.
What are you doing to protect
Yeah.
this data?
Yeah, so I think we would want to be really careful about that. It probably would be more about coordinating services than it would be about like transferring a particular patient's record from one hospital to another. This is a really interesting question, I think, for a group like MST that is actively engaged in supporting hospitals using WinLink right now. I think, you know, I'm much more involved in the infrastructure piece of it, where, you know, at some point I would love it if the AREDN mesh were complete enough that we could partner with someone like MST, who probably has great answer for exactly that question. I don't have a great answer for that question.
And same thing for like internet tunneling. Most of the websites I want to connect to are all HTTPS now.
Yeah.
So,
And I don't think that using this for like shopping on Amazon or something like that is really like what it's there for. I think it's much more like if you want to, you know, be able to get any information from outside of a disaster area into the disaster area, where that might be like weather information or that might be welfare messages or something like that. It's like much more those are the kinds of internet services that we would probably take advantage of for exactly the reason that you point out, right? Is that these things would be encrypted. You know, it's even questionable whether or not we would have the internet bridge at all in an emergency situation. And so it's more likely that the mesh would have services inside of the mesh that we would be making use of, like mesh chat or weather stations that individuals have, or a computer dispatch system, something like that. Yeah. Yeah.
Now, is this something, does it have to be customized software for this mesh, or can it be a simple web server that's plugged into it via the computer?
Yeah, so
Let's say an HTTP, HTML1 only, something that's quick text and but gets the point across in a hurry.
that would totally work, right? This device needs to run the AREDN software to be part of the mesh, but then you can plug any computer you can plug into it, and if it has an HTTP server, that'll just work. Yeah, because it's like I said, it's like it creates a parallel internet, just like you plug your computer into your cable modem, and then you don't care what's running on the cable modem, right? Like you're running stuff on your computer. Just anything that's on your computer would just start working.
So if you were to make like one of them old Citadel servers with the group Citadel, you could actually plug that in.
I think so. Yeah. Yeah.
Because it's got both the text and the web.
Yeah, I'm not familiar with Citadel, but yeah, I bet it would just work. Yeah, yeah, yeah.
Is there any discoverability for IP phones, or do you have any servers for DNS or that kind of stuff to discover these services that are on them?
Yes, that's a great question, right? So Arden does have DNS, and when you set up an Arden node, you have to give it a host name, and that host name has to include your call sign. That's sort of how you're broadcasting your call sign. That call sign then is discoverable via DNS. Arden has this discoverability protocol built in where every node that's part of the mesh ultimately discovers every other node that's part of the mesh. And then it locally is running a DNS server. And then you just ask it the node name. In terms of IP phones, if you know the IP address, you can call it. But you could run a PBX server, for instance, on the mesh, and that PBX server would be a bridge from some friendly name back to the IP address of the IP phone. And that's how that would work. We don't currently have a PBX deployed in the Seattle area. The people that have IP phones are only calling each other up using their IP addresses. But we could totally have a PBX that gets installed. And as long as you know the name of that, like the domain name of that PBX, then you could get the whole directory of all of the IP phones that are in that PBX. I mean, it's literally just like whatever the PBX does. Like Arden has nothing to do with how that would work. Yeah.
You said those are commercial Wi-Fi devices. Is there software for other devices? Like I have an old Ubiquiti, access point. Could I install the software on that?
Yeah. Yeah, almost certainly. So the Ubiquiti, MikroTik, TP-Link, and GL-iNet are the 4 manufacturers that Arden natively has builds for. But the software is actually based on WWRT. And so it's like super generic. There's a bare Linux version that is distributed as a Debian package, and you can install Arden on a computer if you wanted to. If you have some particular device that's not part of the existing build system, you might need to set up a configuration entry because the Arden has like a big JSON file with all the devices that it supports that just identifies information like about the radio basically. And then you would have to do a build for whatever that processor is, but it's totally possible. Yeah. Yeah.
TP-Link devices are fairly directional.
Yeah, these.
If you want to put up a new node and have other people be able to connect through it, it seems like a matter of what direction you point it.
Totally. Yes. Yeah. So.
How do you decide what the best direction is?
That's a good question. So there is, Northwest Mesh maintains a map and a registry of everybody that has submitted their location and information about their antenna and whether it's directional, what direction it's pointed, and things like that. You're right. These have, I think that these have 120 degree. I think that these are 120 degree nodes. I have one at home that I point at an omnidirectional antenna that's on a roof of a big building near my house. I happen to know that it's there. I know that it's there because of Northwest Mesh. Arden also, like Arden, the overall organization, they maintain a map, and in the Arden software, it'll ask you for your grid square. And if you plug that in and the node has access to the actual internet, it will upload that grid square to the Arden map, and then that Arden map is updated. And I think they purge nodes like after 6 months or something like that. So if they haven't updated frequently enough, it'll pull them off. So all the nodes that are on are fairly fresh. So there is a map nationwide, well, worldwide, that shows all the locations of nodes that have opted in to share their location. So that's one way that you can see. I will say that if you want to actually be part of the mesh, it's great to join the Northwest Mesh group and either check out the group's IO for it or come to one of the LinkedIn meetings that we have one of the Zoom meetings that we have every month. Other questions? Yeah.
Sorry. Can you connect a phone to their point directly, or is it just set up to connect via?
Like a smartphone, you mean? Or I mean, it would depend on what the capabilities of the device are. I could your phone is not going to be able to join the Wi-Fi network that's the mesh, right? Because your phone is only going to operate on the consumer Wi-Fi bands. And the AREDN mesh operates in like adjacent frequencies, but they're outside of the consumer band. So your phone won't be able to join that Wi-Fi piece of it. If you had a node that's part of the mesh, and you plug that into a little LAN, and on that LAN you have a wireless access point, then yes, your phone could join the mesh that way, because it's just TCP/IP, right? So, yeah.
So is the performance still based on Wi-Fi 4 or 802.11n technology? When I was looking at the hardware, it seemed like it was all like 250 megabit kind of range, and nothing that was AC or AX.
Yeah, I don't know that they're like all the way on the cutting edge most. I would assume that that would depend on the devices, because those other standards, they run on the same frequencies. Is that right?
Yeah,
And they're just
but there's specific hardware that supports AREDN, right? Because it can operate outside those US bands.
yeah. I mean, I think that it's totally new firmware, right? So
You
it's
can't just take any arbitrary Wi-Fi 6 or 6E hardware and put AREDN. It has to be
y-
specifically developed for that.
yeah. I mean, the AREDN builds there are AREDN builds for specific hardware models. That is true. Yes. I don't know the answer to your question. Yeah.
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 That makes sense. I was just curious if there were any new ones. 'Cause
Yeah. I haven't.
last look, they were real hardware
Yeah. They. Yeah. That's probably
in
true.
terms of Wi-Fi.
Yeah. Yeah. All right. Any other questions? All right. Well, thanks everybody, and I also want to thank Christian Helfrich, who has a booth over there. He actually did a presentation that I based this presentation off of. So, yeah, you should check out his FL Digi booth.